particle, and if you have some oil outside, then this kind of fluid usually is some kind of lubrication oil. So usually, what kind of function we need to consider this kind of lubrication oil? This field usually is called tribology. You have some kind of a machine, and you need to consider what kind of some buffer between this kind of a moving part. So, because if you don't have liquid between this moving part, solid part, maybe they will to each other, they will compact to each other. So usually they have some kind of gap, and this gap usually you will fill with fluid, and this kind of fluid usually is mentioned as lubrication oil. Okay, and basically this kind of lubrication oil, one to diffusion. They can carry out the heat. So heat loss usually is one of function. Another one, because the solid particle, maybe we have some contact to each other. So they maybe have some kind of a small piece. So they need to carry out this kind of small piece to make the motion smooth. So another one is they need to remove some kind of particle. It's not good for this kind of machine motion. Then usually you will have a SAE number. This is a Society of Automobile Engineer. It's from the United States. For example, different car, racing car, you will choose different lubrication oil for the SAE high number or low number. Or if you have a motorcycle, you will choose different SAE as well. Okay, so basically this is related to some kind of boundary layer to the some machine design. Okay, choose this kind of lubrication oil. Purpose is like a lubrication, clean, and inhibit corruption or avoid correction and cool the engine. I think this is the main purpose to choose that. So different number of SAE is related to the two different kind of boundary layer. One is for the heat diffusion. For this one, we're going to talk about LOT. This for the heat diffusion. Another one, you want to carry out this kind of correction that will depend on this viscosity, because this kind of motion that will carry out some kind of particle as well. So if we substitute these two to the Gaussian equation, you can see basically this length is the square number of a Prandtl, because the Gaussian equation that should be the square. Okay, so your Prandtl number compared to the boundary layer by the momentum and the thermal boundary layer by the temperature, they will relate to the square of a Prandtl number. So use this, we can estimate the laminar flow. Okay, the boundary layer for the turbulent, that will be another story. Okay, they will shorter and more close to the boundary. But here we talk about is for the laminar boundary layer. Okay. Okay, so for the general Gaussian equation and the boundary condition, in many of the cases, we will use the dimensionless parameter. So first, what difference between the Gaussian equation and the boundary condition? So what difference?
Current condition is for whole space and boundary condition is for just for boundary.
Yeah, in the whole flow field or in the all that domain, in all the domain, your Gaussian equation must be satisfied. So that means you choose any point, any time in your flow field. You substitute their velocity, pressure, temperature into a Gaussian equation. They must be satisfied. But boundary condition only on the boundary. Okay? So for this kind of unknown, usually we want to solve the maybe velocity, we want to solve the pressure, or we want to solve the density in case for the compressible flow. For incompressible flow, then this usually is a constant. Or we want to solve the temperature. Then we have a function. The most common function is a space, x, y, z, and the time. This is usually we look at. But sometimes your viscosity or your heat conductivity, they will change because they are thermodynamic property. You have a different temperature, your viscosity will change. Your heat conduction will change. That's why we talk about location that have a SAE value, because of different temperature, they will have a different kind of viscosity, and also they have a different kind of heat conduction. Then other parameter, maybe you can look. The textbook is like the heat condition, or for the sleep condition, or different kind of force. Then for this, if we want to make the Gaussian equation and the boundary condition to become to non-dimensionalized, usually we need to have some reference property. Reference velocity or reference length, that's most important. Other property, reference pressure, maybe reference the density, this sometimes we will use. Then you can see in the Buckingham pi theory, we can make our dimensional equation to become to a non-dimensional equation. So what the purpose or what the advantage for this non-dimensional parameter? For this procedure, what the advantage?
Because we don't consider the dimension, so we can, because the dimension is, so we can use a more condition.
More condition.
Because they just a value, so we can use this dimensionless equation to solve more efficient.
So more general, for more general problem, right? For example, I give an example about the laboratory experiment. If we have a laboratory experiment for the airplane, should we do the same size of an airplane? if we do the experiment for the car, should we do the same size of a car? So if we use the dimensionless, this parameter, the first, we can make a different size of the experiment to predict the prototype we're going to do. This is one of the advantage. Another advantage, I think is commonly taught in your undergraduate.
When we have the dimensional equation, we can do like the dynamic, the similarity or something.
So what does it mean? Dynamic similarity. Yeah. Yeah.
Say相似性，动力相似，运动相似。
Yeah. It's like a force similarity. For example, we will consider viscosity force and maybe the inertial force. Or inertial force compared with the gravitational force. This is later the non-dimensional parameter we're going to talk. But before that, we like to talk about this procedure. Then, for example, we can reduce the size of an experiment. Then, if we reduce the size of an experiment, so how can we predict to the prototype? And does this come out certain of advantage of a non-dimensional procedure?
We can set the money to building the experiment. Because we're doing the dimensionless this part, and it can help us to maybe just set the money to create a. We don't need to build a huge build.
Yeah.
So we can just
Reduce the size,
Yeah,
but
yeah.
sometimes we want to increase the size. Because if they are some very small, we cannot do that kind of a small. Then we will enlarge. So your undergraduate teach you what's advantage for the non-dimensional parameter, this procedure.
Maybe we can change another liquid.
They will change it another liquid. Of course, we can change. Then, anyone have an idea? Supposedly, this is the undergraduate.
Maybe after these procedures, maybe we can find some like major parameter about
Yeah.
this field.
Yeah. So what does mean the major parameter?
Like Reynolds number or
Are they unknown or they are unknown? So in the mathematical equation, this usually why we want to have a mathematical equation. If there are some constant, should we have a mathematical equation? If mathematical equation is give us the way to get some unknown we want. For example, this unknown is like the U, this unknown is like the P. Okay, so in the dimensionless procedure, can we reduce the unknown? I think in your undergraduate, it's talk about physical parameter through the non-dimensional parameter can be reduced the unknown. Then how they reduce the unknown? Buckingham pi theory, right? Buckingham pi theory tell us if your physical parameter is like a 7, then your dimension is like a 3, then you can reduce physical parameter into 4. Let's reduce the physical parameter. Then, similar to the reduce the size. For the reduce the size, we are looking for experiment key dimensionless parameter. So this key dimensional parameter we use to predict prototype, the real full scale. So 2 key dimensional parameter will be the same. It's not physical parameter. Okay? So basically from this procedure, Buckingham pi theory, they have some equation k minus r equivalent to, right? So usually this equation tells us what? Your dimensional parameter usually is less than physical parameter. Then that is that you reduce complicate of the problem. Because more unknown or more physical parameter, that means the problem become more complicated. If you have original 4 unknown, then you can reduce 4 unknown become to 1 unknown. That means you just need to do 1 set of an experiment. If you have a 4 unknown, that means you need to do 4 set of an experiment, right? So this is also 2 different kind of non-dimensional parameter advantage. Reduce the unknown number, and you can do the experiment in the laboratory size depending on this non-dimensional parameter. Okay? So after we doing the non-dimensional, I think you can practice by yourself. So I will not do that procedure. For the mass conservation equation, and I think there is a typo here, because this is a space derivation. Okay? This is space derivation, so you must make your space derivation non-dimensional by the length. Choose the characteristic length to make this space derivation to become to the non-dimensional. Then for the mass conservation equation, usually they don't come out any non-dimensional parameter. But for the momentum, or so-called Navier-Stokes equation, energy equation, you can see they will come out of a momentum equation. And for the energy equation, they will come out non-dimensional parameter. Okay? So usually for the momentum equation, you will come out the flow number. So flow number which term is cancelled out. Anyone have an idea of flow number? No? Okay. Later. How about Reynolds number? What does Reynolds number mean?
Like the physical force over sorry, like the 关系分子电磁体。
You come into a Mandarin. That's viscosity, right? Viscosity with the inertial force. Okay? So basically this is a viscosity term, right? And basically the P star sometimes they we refer as Euler number because
P.
the pressure can be regarded as non-dimensionalized. Because of momentum equation, you can see this is the pressure term. This is the viscosity term. So, which term is for the flow number? Momentum equation, right hand side, 3.
Gravity.
Yeah, so this is gravity term. So, flow number, that will be gravity compared with the inertial force. Okay? So, usually, I think student can write exam question, no problem. But, what's the inertial force?
That is the just about the mass.
Hmm?
About it self stands like flux.
Velocity?
Nah, that's not quite sure.
Anyone have an idea? So what the inertial mean? Inertial is Newton first law. So what's the first law tell us?
Like
Stationary. They will keep it stationary. So if your material without any velocity, do they have an inertial force? No, because the velocity become to a 0. Then if your particle has a certain of a velocity, Newton first law tell us what?
There's a force.
Hmm?
There's a force.
No, they will keep the motion. They will keep the constant velocity motion. Unless what? Unless external force. So if you want to stop this constant motion material, then that's inertial force. How you stop this the constant velocity? So that's on the right hand side. Sorry, on the left hand side. The left hand side, they tell us how to make this become to a 0. They have a certain of a velocity, then they will become to a 0. This will contribution the external force for the inertial force. So you divide the left hand side into every term. Then that's why flow number is a gravitational force compared to the inertial force. This pressure or Euler number, pressure compared to the inertial force. Similar, this Reynolds number, viscosity compared to the inertial force. Okay? Usually, I think most of the students can answer the inertial force, but if I ask the inertial force definition, maybe 90% they're not quite sure, or they cannot answer properly. This is based on the Newton first law. Newton's second law, right? The momentum equation. Okay, so the next week we will continue to talk about heat transfer and remember energy equation include two different energy. One thermal energy, one mechanical energy. Two different energy. They will come out different kind of dimensionless parameter. Okay.